Hello and welcome everyone to this learning series of data science for consultants. In today's session, I will illustrate data mining techniques commonly used in initial phase of data analysis. It is where we usually slice and dice our data to find more insights. Later on, I will also demonstrate the descriptive analytics usage of data mining. For this, I will be using SAP Business Object Predictive Tool and introduce you the basic concept in this tool. Data mining help find key data attributes and filters out the not so relevant data. The relevant data variables can then be used to build model, and we will go through this step by step. The key is to build deep understanding of the data and to find insights on the data. So let's get started. So on this, we are on the welcome page of the predictive tool. We'll be using the expert analytics functionality of the tool, and we get into this. Here we go. So we have the dashboard for expert analytics, which you see different features in it. As a first step, we will be acquiring data, and it's as simple as clicking this. For this session, as you see, I have used some data sets in the past, so I have already pulled up, but for somebody you can always go to select the data set you have, and then it prompts you to pick up from the library we have stored. As you see, it could connect to virtually any data source anywhere you have stored. So for this demo, we will use SAP stores data. So if you see this data, it is about different stores and have 4 different attributes. So stores are located in different cities and we have 4 different attributes. Turnover is an aggregate of 12 months in millions. In millions. Size is in thousands of square feet for each store. Staff are in 10, so this is basically 61 staff. This is 15 staff here. And this is the gross margin per store in 100,000s. So this is how this data has been laid out. So let's move on with our exercise in acquiring data. So the data has been acquired, and we can see from here all our data has been acquired. You see there are some data cleanup activities required. There are some fields which have not been clearly identified. So we will go to visualize, where we will do some cleanup or data preparation activities. The very first thing we'll do, just for definition on measures and dimensions. Measures are your quantitative data and dimensions are your categorical data. So for example of categorical data could be people, product, place and time, whereas measures could be, as you see, margins and number of staff or turnover. So those are pretty typical measures. So first thing, since you see there are different data types, and by just here you can see it's numeric, and this is a geographical data. So we will try to create a hierarchy so we can expand this geographical data to granularity of city, so it's easier for us to do some data analysis on this. So to do that, it's pretty simple. We go and create hierarchy by geo dimensions. We confirm, and here we go. So this is a summary page. As you see, the software found some ambiguity or discrepancy in some of these store locations. It has also given us some recommendations. So what we'll do is we'll just go in, and for this I'll just take randomly some of the recommendation so that we have geolocation for these cities we have. I'm just doing random um, so that our analysis is as clean as possible as we move in the exercise. Okay, so we have tried to resolve most of this. This is done. And now what you will see is on the left side, this geography is now broken into 4 different stores or 4 additional regions. So to continue with this our analysis, we will use some of the different visualization techniques here and try to gain some deeper understanding of our data. So first we are trying to use this bar chart, and it's as simple as dropping on the canvas here, and I can drop a store here, and you see it forms. So it's pretty intuitive when it comes to drag and drop and play on this. We can also use different filters, um, and we can also use labels and things which I will show you as we move. In this since this is just 2 variables at this point, we can also very quickly add another variable, and it, as you see, it gives a multi-variable picture of our bars. We can also put sizes, like if you want to see stores in different colors, it gives the stores in different colors. So different visualization techniques are used here. As you see, the use of this is very friendly. It's basically drag and drop on this canvas, and we can get multiple views. We can add filters. So let's take a different measures and dimensions and create a different view of this. So to do that, I will just refresh the canvas, and let's do this turnover with on stores. So basically what we are trying to look is, okay, what is the turnover per store? In this we will try to put a filter, and we like to see the top, say we like to see the top 10 stores. Here you go. As easy as that. And then if you want different colors on your legend, you can have different colors. As you can see, now we have top 10 stores with turnovers, with Santa Clarita being the most having the most turnover. So moving on, let's see a different view, and in this time we'll try to use the geography on the canvas to showcase our data. So let me refresh this chart again, and this time we are going to use the geographical bubble chart here. Then let's put our measures. Just want to see, let's see again city, and maybe we want the color of by size. So what we are trying to show here is margins per city by size. So as you can see, the bubble is by margin. So bigger the bubble, more the margin the stores are making. You can see, but also we can see that there are some stores which seems to be in Russia and Alaska and somewhere in Pacific, Honolulu. So, and in Africa. So definitely looks like data needs to be more cleanup. So we will go and do some clean up on this. The way to do that is you go to geography and do edit reconciliation and try to resolve some of the issues which we see here. We say salt and we say anchorage, so that's probably right. We saw St. Petersburg and St. Louis, which showed in scrolling down. So we see St. Petersburg. It does show Russia. I think we want it to be in Florida. And we had St. Paul, which is, and this is Senegal. So we need to do St. Louis. I think if we do that and refresh our canvas, it now brings most of them here. What we can also do is we could always restrict these more by regions. For example, I just want to see say California, so I can just apply that and you get a quick view of all the stores in California margin as our denominator for the bubbles. So moving on, we will look at the scatter matrix. Scatter matrix is very important because it gives you an understanding of possible outliers and different groups within a data set. So to do that, let's again clear the chart. And in this case, we will select the scatter matrix. We'll do a matrix chart here. And then we will drag all our measures here so we can get a full picture. Turnover, and we would like to do this by store. Voila. As you can see on the margins, we can always see that it looks like there are always two groups. So just by your initial visual look, we can see that there are two groups of stores in this. Let's move on with some other techniques. Do a bubble chart this time. And again, for do that, let's reset our canvas. And we will, this time we will take a bubble chart. And we will use turnover this time. And on the y-axis, let's use size. And the bubble width, let's use the staff just for this exercise. And always legend color should be by store. As you can see, there's we can see the staff size. We can already see that Santa Clarita has a bigger staff size. We can, let's filter it and let's see how California looks like. Region, we'll pick California. Here we see there are very clear interesting stores. For example, on the top right, Santa Clarita has a large staff turnover and size. However, just underneath there is a similar size bubble representing Moreno Valley that has a similar staff and turnover but less store size. This is something to note. It will also be interesting for the organization to understand why this store can achieve similar turnover with the same number of staff but in a smaller retail area. So there are some investigation to be done, and we can see there are some other stores which can fall into the same category if we start looking into deep. So let's move on for some other ways to do data analysis. Before moving on, let's try to clean up the canvas. Again, we will reset this, and this time we will try to work on heat maps and tree maps. Heat maps provide us a very useful comparative data insight. It's a best way to look at comparative data in the heat maps. As we already have discussed, heat maps are very useful for comparative data insights. So let's build our heat map. So we'll use tree map, and we will use let's use size our area weight, area color is turnover, and area name as stores. And you can see based on turnovers we will see the heat map. Let's add a filter on our favorite region, California. Now you see our top stores with turnover. As you can see, Santa Clarita and Moreno have the top. We can also, if you want to add a label, you can always go here and show data labels. So this also shows the turnovers. So it gives you a point-to-point view of that. So I think this is a good exercise and we can see in a one shot. So let's look at a different view. Before we move on, let's refresh this data. And this time we're going to look at parallel coordinates. It's a very powerful data representation, especially to see outliers and potential groups in data. So we will do parallel coordinates. And for this, let's use all our variables. As you can see that there are possibly two or more groups of store. Looking at the vertical axis of margin here, you will see that stores are grouped in possibly two regions. And this is also true for staff axis. You can see there is a distinct two region. Interestingly, higher margin stores seems to group with higher staff, and lower staff is relatively linked to lower turnovers. That is an interesting insight. So the next step is, once we do data analysis, we always go and try to create a model. And I think this is giving us already some picture or some insight that this model, if we make a segmentation model, this will help us understand the characteristics of this store more better, and we can get some more better insights from it. Okay, let's move on to a different technique this time. So before we move on, let's refresh this chart. Always. So in this section we will talk about radar charts. So I'll show you where it is. The radar chart. It's a very useful chart to compare different dimensions, and it points to some unusual values. So let's build a chart here for us. Let's use all our variables: size, turnover, say add staff, and we'll add margin also. And on the branch we will use store of course. And it's very busy. Let's filter it by size of, we'll just take say top 15 here. Sorry, top 15. Here we go. So we are looking at top 15 by size, then turnover and staff and margin. and there are different ways you can look at the detail. You can already see Santa Clarita, a little bit out of roll. You see Little Rock also, which is interesting. Maybe needs to get to a little bit more further study on these stores. So again, this provides a very good different study of different dimensions and sometimes points to some unusual values here. So let's move on, and this time we will trying to do descriptive analytics. So as we see, we have already seen most of our data mining slash analysis methods available on SAP Predictive tool. So let's do some descriptive analytics. Okay, to move on, let's go to the predict phase. This is where we're trying to do descriptive analytics. You see there are algorithms. We are not using it because we're just going to do some basic analytics on our data and try to infer or interpret some obvious insights. So it's pretty simple. We have our data sets already highlighted. All we do is run, and here we go. We get our results here. As you can see, it has all our value. Let's go and check the statistical summary on it. Here we see. You can see the very first thing is turnover. This beautiful bell curve here. Good normal distribution, as we can see in this data. If we scroll to the right, we can see there are more columns like variance, average, sums, min max values. So there are a lot of good statistical values available here for us to look. And we can also see they have a total count, so all our data has been accounted for. What we can conclude at least here is the distribution for turnover and size looks fairly normal, but however the distribution for staff and margin are more bimodal with two distinct peaks, as you can see. So I think this will definitely need some more analysis here. As we can see, why is this happening? Why are these different peaks and under what circumstances? So this could be a subject of more analysis. So this is how descriptive analytics work. So you run an algorithm against a general statistical values, and you can get some basic ideas. You can also see it had created us the parallel coordinates charts for us. Again, we have already gone through. You can see how there's very obvious visual segmentations for margin. Looks like there are two different set of stores following two different rules. So definitely there is a lot of insights available here. And we also have seen the scatter matrix chart, which also shows us, as you can see, two distinct groups coming out, which means that it's very obvious that there are two different groups which have some hidden meaning. So this would be the end of today's lesson, and we will see you next time. Thank you. Bye.